Hello friends, welcome to the mathematical room. I am the caretaker. So we have just finished a series on permutations and combinations, and I was supposed to come back with the binomial theorem. We will do that, but today I decided to see something else. Okay, something different than what we usually do. So let's just go through this question and see what it asks. It's about this question. Okay, so we are given a pack of 52 playing cards, a standard pack of playing cards, and a fixed scheme of shuffling those cards, right? If you have played cards, you know that to mix them up properly, we have to shuffle them, right? Now, when we shuffle the cards, usually we do it randomly. Okay, we do not keep track of which card is going where. I mean, we just simply shuffle. Or in some magic trick, if a magician is asking you to mix the cards up, then you will do some sort of random shuffling. But here, what we are given, we are given a fixed scheme of shuffling. That scheme may be extremely basic. Say you cut the deck in half, okay, in two equal halves, and you switch the places of those halves. The one which is on on the top of the other one, so it now comes below that one. Okay, so it may be that scheme, or it may be something more complicated than that. Say the first card goes uh, below the deck all the way down, maybe something like that. So a scheme of shuffling is given to us. Now if we are given the deck, then initially the cards are in some sort of arrangement. Starting with that arrangement, if we apply the shuffling scheme once, the arrangement will change. Now, if we keep on applying the shuffling scheme again and again, at some point we will come back to the initial arrangement from where we started. So we have to find the least number of times we have to apply that shuffling so that we get back the initial arrangement, right? So at once, if you think of this problem, it seems like it involves permutations. And in fact, it involves permutations. But the thing is that so far the questions we have considered on permutations, okay, they have been of the nature that we were asked to find the number of permutations, or we have in fact, in the course of finding those numbers, we have in fact sometimes taken some examples where we wrote down the actual permutations. Okay, now this is not a situation like those, and I mean it's not like those problems what we have considered so far. So we have to investigate the situation from scratch in this case. Now, of course, I will not consider 52 cards and see what happens, because 52 is a large number. So to understand the situation, I will take less number of cards, and to not oversimplify the thing, I will take some number of cards. I mean, not 2 or 3, but 9 cards. Okay. So, say these are the cards. Without actually calling them like king of spades or seven of hearts, to make matters simple, I have labeled them using just natural numbers. So you have to understand that these are not just numbers. These are labels that have been given to some cards. Okay, 9 cards. Now, what is my shuffling scheme? My shuffling scheme is like this. So initially this is the arrangement. Now note that I don't know what the cards here are. I mean, I know, but that does not matter. initially they may be in some sort of arrangement. This may be 7 of hearts, okay, 6 of spades, something like that, etc. And they have been labeled using these numbers. Now my shuffling scheme is this. The first one goes to the second place. The second one goes to the third place. The third one goes all the way to the ninth place. Okay? The third one goes to the ninth place. The fourth one does not change. The fourth one stays in its position. The fifth one comes to the first place. Right? The sixth and seventh ones, they switch positions. The eighth one stays the same, and the ninth one comes to the fifth place. So this is my shuffling scheme. Same, some random shuffling scheme, but nevertheless it's the shuffling scheme. Now what I do, so this is the arrangement. I apply it once. Apply the shuffling scheme once on this arrangement, and the arrangement changes. And this is the new arrangement here, which starts from 5 and then goes like this: 5, 1, 2, 4, 9, 7, 6, 8 and 3. Now I apply the shuffling once more. Okay, so let's just go through this a few number of times. So the first and second one, they come to the second and third position, right? 4 stays as such. Then this one, the fifth one comes to the first position, so 9 comes here. Okay, so then after that the last one comes to the fifth position. 6, these two switch places, so they were 7 and 6 here, so now they become 6 and 7 again. And eighth one stays as such. And finally, what is this 2? This 2 was here. Oh, the third one goes to the last position, just like here. Okay, so keeping that in mind, we apply this. Okay, let's just go through it once and see if we have got it correctly. 9 comes here, 5 comes here, 4 stays as such, 1 goes all the way to the last position, right? 3 comes to the first place. Okay, 6 and 7, they switch places, and 8 stays as such. After that, 3 and 9 will come to the second and third place. So second and third place. Okay. Then after that, 5 will come to the last place here. Then 4 does not change. 4 and 8 do not change places. They stay fixed. Then this is the fifth one, 2. So it will come to the first place. So it has come to the first place. 7 and 6 again switch places, 6 and 7. 8 stays as such. Just like that. 2, 3. We don't have to care about 4 and 8 anymore. 9 goes to the last place. 5 comes here. And 1 comes here. 6 and 7, they keep switching places. So this column is also okay. 6, 7, 7, 6, 6, 7, 7, 6 is going like that. Right. Then 1, 1, 2, 3 goes to the last place. 9 comes to the first place. No, sorry. 9 comes to the fifth place. 5 comes to the first place. 5, 1, 2 goes to the last place. 3 comes to the fifth place, 9 comes to the first place. 9, 5, 1 goes last, then 3 comes to the first place, and 2 comes here. 3, 9, 5 goes to the last place, 2 comes to the first place, and 1 comes to the fifth place. Finally, 2, 3, 9 goes to the last place, Okay, so 1 comes to the first place and 5 comes here. So you see that this is the initial arrangement. 1, 2, 3, 4, 5, 6, 7, 8, 9. Right. Now let's see how many times we have to apply the shuffling scheme. We have labeled the number of times, okay, the applications of the shuffling scheme. So we had to apply it 10 times. I mean, we can keep on going like this. After the 20th shuffling, we will again come back to this because the same thing will repeat. Okay, well, if we keep on going like this, the same thing will repeat. But we have to find the least number of times. We have to shuffle them to get back the initial arrangement. So we see that if we are given 9 objects, and this is my shuffling scheme, this particular scheme which is given by this place, okay, in going from this arrangement to this arrangement, the scheme has been shown. Then this number, this least number of times we have to shuffle the deck to get back the initial arrangement is 10. Okay, but what is this number 10? We are not concerned about that. We want to be able to find the number 10 without doing all these things. Okay, there should be something in this shuffling scheme that will tell me that this number is 10. We want to find that, right? Now, looking at the shuffling scheme, I can see it looks somewhat complicated. You see, it looks like this: 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, 5, 1, 2, 4, 9, 7, 6, 4, 9, 7, 6, 8, 3. Now in showing what is happening, I have used arrows, right? And it looks, I mean, we can see what is happening. 3 has gone here, 9 has come here, and they switch places. 4 and 8 they stay fixed, they stay the same. But this is an extremely bad way of representing this shuffling scheme. Can I do something better? Can I formulate a notation which expresses this more neatly? So, looking at this arrangement, actually this is the thing that I want. 5. I want to know that 5 comes to the first place. Okay. So, if I write like this, 4, 5, 6, 7, 8, 9, and what I do, 5 comes to the first place. So now my objects are these. These were the objects initially. 1 goes where? 1 goes to the second place. So if I keep track of the place numbers or the place labels, 1 goes to the second place. So if I write 2 below 1, okay, then I will know that 1 goes to 2, or 1 does not go to 2, 1 goes to the second place. The numbers that I will write here, they denote places, whereas the numbers on top of them, they denote the objects or the cards that we are shuffling. So 1 goes to the second place, 2 goes to the third place, 3 goes to the ninth place. So 3 goes to 9. 4 stays, it does not change place. 5 goes to 1. 5 goes to the first place. Then 6 and 7, they change places. 8 is unchanged. And 9 comes to the fifth place. if I denote my scheme like this, then I don't need any arrows anymore. Looking at this, I know which card is going where. Okay, the card 1 goes to the second place, card 2 goes to the third place, and so on. Now this looks more neat. Okay. Now one thing you also notice here, to see what is happening in this whole uh, applications of the scheme, okay, many number of times, we don't have to consider 4 and 8 because they are not contributing anything to the arrangements, they are staying fixed. Now I will try to break this down into something simpler, even simpler. I mean, this is just a notation which shows the shuffling scheme, that's all. It does not show anything more than that. But I try to devise an even simpler notation which will show me what is actually going on inside this shuffling scheme. So what I mean by that, the question we have understood. So let me wrap this up. And I am going to devise a new notation to see or show what is going on inside this shuffling scheme. Okay. Now according to my new notation, I still have to represent this full information. Which one is going to what place, which card is going to which place. So what I do, I start with card 1. Okay. Now since I have not actually written or rather distinguished between the cards themselves and the places that they occupy or going to occupy, so I can take advantage of this identification or indistinction. Card 1 goes to the second place. Okay, so I write 2 after 1. What it means, the number that is appearing after some number. So it's the place where this previous card is going. So 1 goes to the second place. But this 2 also represents the second card. The second card goes to the third place. So I write 3 here. So I don't have to write 2 rows of numbers. I can represent the same information using only 1 row. So according to this scheme of writing, what will happen next? 3 goes to 9. 9 goes to, so I have taken care of 1, 2, 3. Now 9 goes to 5. So I write 5 here. Now if I look at 5, 5 goes to the first place. So 5 comes back to 1. So instead of writing 1 here, I complete this cycle. This is a cycle. It is a cycle because it comes back to the same thing from where we started. 1 to 2, 2 to 3, 3 to 9, 9 to 5, 5 to again 1. Okay, so these are the things we have taken care of. Right? Since this cycle has 5 symbols in it, let me just call it a 5 cycle. Okay? So this much is done. What about the rest of the objects? 4 does not change itself. Actually I can write 4, but since we have decided to not keep track of these 4 and 8, so we do not bother to write them. Now what I do, so this part is not needed, this part is not needed. Now 6 and 7 are there. So according to the same scheme, I then again start with 6. What is the, where does the card 6 go? 6 card goes to the 7th place, and 7th card comes back to the 6th place. So here the cycle ends here itself. So it's a 2 cycle. Okay. But what is the advantage of this? Is it just simply a device for writing this whole thing in a short manner? No. Besides writing this whole thing in a more compact manner, these cycles tell me something about this number 10. Let us now go to the actual calculation. You just let us just keep track of what is happening to the first card as we are applying the shuffling scheme. See, here is the first card. When we have applied it first, the shuffling scheme, it has gone to the 2nd place. After that, it has gone to the 3rd place, right? After that, it has gone to the 9th place. After that, it has gone to the 5th place, and after that it has come back to its original position. How many times we had to apply the shuffling scheme to do this? 5 times. 1, 2, 3, 4, 5. Right? What about 2? You see, if you look at these cards, first card, second card, third card, ninth card and fifth card, they have actually come back to their original positions after the fifth iteration. You see, 1, 2, 3, 5, 9. 4 and 8 are fixed, we don't care about them. But here there is a problem. Instead of 6, 7, I have 7, 6. So this is actually not my initial alignment because of these two things. Okay? Had they been 6, 7, I would have stopped this here itself. But that I don't have, so I have to keep on applying the shuffling scheme. But what do we understand from this situation? We see that if we apply the scheme 5 times, then these symbols come back to the same position. But why? Actually, that is because of the fact that this is a 5 cycle. But that's still also why. You see, when we apply the shuffling scheme, 1 goes to 2nd place. Then it goes to the 3rd place. Then it goes to the 9th place. Then it goes to the 5th place. And then again it should come back to the 1st place. And that has happened. 1 goes to the 2nd place, 3rd place, 9th place, 5th place, 1st place. Is it the same for 2? It is the same for 2. Now, but why? Why is it same for 2? It's because, you see, instead of this 5 cycle, if I write like this, 2, 3, 9, 5, 1. Now, according to our way of writing, according to the definition of this notation, are these two cycles different? They look different because this is starting from 1, this is starting from 2. But actually they are not different. See, what are they saying about the scheme? They are just saying that the 2nd card goes to the 3rd place, 3rd card goes to the 9th place, 9th card goes to the 5th place, 5th card goes to the 1st place, and 1st card goes to the 2nd place. Same information. So it does not matter whether I write the cycle like this or like this. What I have to maintain though is the cyclic order. After 2, 3 comes. After 3, 9 comes. After that 5, 1 and then back to 2. So that's why it is called a cycle. Okay, it goes like this. 1, 2, 3, 9, 5, 1. Okay, it goes like this. It does not matter where you start. So the argument that I have gone through to conclude that 1 comes back to its position after the 5th iteration, that same argument tells me that 2 also comes back to its position after the 5th iteration. And the same is true for 3, 9, 5, and 1, of course, we have considered already. So to take care of these symbols 1, 2, 3, 5, and 9, I need to apply the shuffling 5 times. But doing so has created this problem. Okay. Now, before we go considering 6 and 7, let us just also see one more thing. You see, after applying the shuffling scheme 5 times, I have got these elements to their places, to their original places. But I have actually applied the shuffling 10 times. So then that means again running the thing 5 more times. First 5 iterations, then next 5 iterations. They will come back to their original places again once more, right? Because you see, it's just the same calculation for 1, 2, 3, 5, and 9. Coming from here to here is the same identical thing as coming from here to here, because we are again going through the same steps. You see, 5, 1, 2, 9, 5, 1, 5, 1, 2, 9, 5, 1, 3, 9, 5, 3, 9, 5, 2, 3, 9, 2, 3, 9, okay, and so on, the other things. So that means I can apply the shuffling scheme either 5 times or 10 times or 15 times. That will not change these symbols if they will keep their positions. Now we come to 6 and 7. 6 and 7, this situation is somewhat easier, much easier than what we have here. It's a 2 cycle. So what is really happening? They are switching places. Every time we apply the shuffling scheme, they are switching places. Here 6, 7 has become 7, 6. Then again 6, 7, 7, 6, and it goes on like that. So we apply the shuffling scheme once, it becomes 7, 6. We apply it once more, it becomes 6, 7. So just in 2 iterations, we get back their positions. 6, 6, 7, 7. But we cannot apply the shuffling technique, shuffling scheme only twice, because doing that does not keep these elements fixed, 9, 5, 1, 3, and 2. So that's why we have to apply it 10 times. By the way, what is 10? You see, the fact to get these things fixed, I have to apply the scheme 5 times. To get these things fixed, I have to apply it 2 times. And I can apply the shuffling scheme keeping these things fixed. Any multiple of 5, k times 5, and these things are fixed by applying the shuffling scheme any multiple of 2 times, number of times. This is not k, this is something else. So that means this number 10 should be a common multiple of 5 and 2, because then only the things will keep their positions, the cards will keep their positions. So this number has to be a common multiple of 5 and 2, but remember that we are after the least such number. So that means the number is the least common multiple of 5 and 2, which is nothing but 10. Okay. So now my analysis is complete. what have I learned from this? First I write the first I see the shuffling scheme, then I write it in that fashion, where I have the initial arrangement on top, and below that I have the uh, labels of the places where the cards are going. Then looking at that symbol, I write these cycles, or I find these cycles, which is rather easy. Okay, you just see which one is going where, and if something is coming back to the place from where you have started, then you get one cycle. It's what will its length be? That depends entirely on the shuffling scheme. If some symbols are left, then you start with them and then again find another cycle. So in this way, you break the original shuffling down into some cycles which involve distinct or should I say disjoint objects. Because you see 1, 2, 3, 9, 5, 6, 7, if you take two sets, the sets of these symbols, these sets are disjoint, there is no common element. Then you find the lengths of these cycles. Here it is a 5 cycle, length is 5, here it is a 2 cycle, length is 2, and then you take their LCM. If there are more cycles, then you have to take the LCM of all of their lengths. That will give you that smallest number of times the shuffling technique scheme has to be applied, so that we get back the entire original configuration. Now let's apply this to yet another shuffling scheme. But now that we know what to do, we are not going to do this. Okay, we will just see, we will just carry out the calculation, not the entire thing, but what we have found. And then after that we will draw our conclusion, final conclusion. Okay, so the next one is this. Let me start from here itself. 1, 2, 3, 4, 5, 6, 7, 8. Now instead of 9 objects, I'm taking 10 objects. Okay, excuse me. Now this is the shuffling scheme. 2, 3, 5. I have it written for me. 6, 4, 1. 6, 4, 1. 10, 9. 7, 8. Okay, so looking at this, I know what is happening. The first card goes to the second place, second card goes to the third place, third one goes to the fifth place, and so on. But now I have 10 cards, or because we are dealing with a card problem, they are cards. They can be any objects, okay, any distinct objects. Now here I find the cycles. Okay, so cycles. So I start with the first one. The first card goes to the second place. First card goes to the second place. Second one goes to the third place. So I write 3 here. 3 goes to 5. 5 goes to 4. Then 4 goes to 6. 6 comes back to 1. So this is one cycle. Okay, it's a 6 cycle. So I have taken care of this part. Now I look at these symbols. So I start with 7. 7 goes to 10. 10 goes to 8. 8 goes to 9. Now 9 again comes back to 7. So this is another cycle, which is a 4 cycle. So the number of times we have to apply this shuffling technique to get back the initial arrangement is LCM of 6 and 4, which is 12. 12 is a common multiple of 6 and 4. Both 6 and 4 divide 12 and it is the smallest such common multiple. So it's the least common multiple. So we have to apply this 12 times to get back the initial element. If we apply this 24 times or 36 times, that will also give me the initial element, but this is the smallest number. Okay. So using this technique, we can now answer the card problem. You will have 52 cards, so it will be somewhat large, but you can see that once you have understood the method, it's quite easy. In fact, it's so easy that one can write a C program for finding this out. Right. Now some things which are going to come in the future. This symbol that I have written, which keeps track of which card is going where, this symbol is called a permutation.